Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey, everybody. Welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And I just love spending our Wednesday nights together where we're just going through math problems, solving them together, processing through them together, and just building that confidence, like Dr. A said, in being able to solve these problems on our own. A huge chunk of these tests is not the actual skills, but it's having the confidence that you can do it. And so I love building that confidence in people. We are here every single Wednesday, like Dr. A said. So if this is your first time, welcome. We are so excited to have you. You might be wondering if this is your first time, because we talked about it last week, why there's some balloons on the screen. It is my birthday week. We don't just celebrate a birthday day in my house. We celebrate the whole week. I don't know. I like to think I celebrate the whole week. We've done nothing yet to celebrate my birthday, mind you. My birthday is on Friday, so it's a little birthday edition of Learning Liaisons Wednesday Night Math Night. I did say to bring your cake. I forgot my piece of cake. I have a gluten allergy, and so I can't just go to the store and buy a piece of cake. I either have to make gluten-free cake myself, or I have to go and get it like from somewhere special. Publix actually has a really good gluten-free cake. So if you have friends that are gluten-free, Publix has this like tiny little raspberry cake. It does not say gluten-free on top of it, but it is gluten-free. In the refrigerator section, you just have to read the ingredients. It is so good. Nothing Bundt Cakes is also a really good one, but we don't have one that's super close to the house. It's like 20-30 minutes away. So anyways, all of that said, it is my birthday this week. I love celebrating birthdays. So my husband and I are going to celebrate Friday and Saturday. And my work celebrated me today, which was super fun. Before we get started, I always like to do, thank you, Martha. Before we get started, I always like to do a little get to know you. So in the comments, let me know where you're from, what test are you prepping for? And are you a cookie cake, regular cake, ice cream cake, or no cake and you prefer like donuts or cookies or something else? What kind of cake person are you? I love a good cookie cake. I haven't had one since I went gluten-free because no one sells a gluten-free cookie cake that I've found yet. I love a good cookie cake. I don't love ice cream cake, even though ice cream is literally one of my favorite foods. And like cake, I could take it or leave it. So I guess cookie cake would be my first go-to. And then like cake if I had to. Like, oh, a good funfetti cake is good. I like a homemade boxed with the box icing cake. I do love that. So what kind of cake do you like? Where are you from? Well, more importantly, where are you from and what test are you prepping for? Because that's going to help us develop our like rabbit trail sidebar conversations if I know who's in the room. And then what kind of cake person are you? Cookie cake, ice cream cake, regular cake, no cake at all. So yeah. And then also, if you think of things that you want to see me go over in the upcoming weeks, let me know and I will add them to the next week section. So if you think of anything that you want me to go over or that you're like, man, I wish she would have gone over this, let me know. You can always send me questions on our Facebook page, the Learning Liaisons Customer Hub. So that's another option that you can always do is send me questions there. All right, I think that's it. Without further ado, let's go ahead and get to our first problem. A teacher presented the following problem and student A solved it below. Most likely, what is the student's error in analysis? Now let's read the actual problem before we get going. Jamie is having a cookie party. Her cookie recipe calls for 2/3 cups of sugar for each batch of cookies. How much sugar will Jamie need if she plans to bake 4 batches of cookies? So that is the word problem that we're dealing with. And now we are trying to figure out what is the student's error in analysis. And here's the student's work. What is the student's error in analysis? And that is the student's work. So A, the student does not understand how to multiply. B, the student does not understand the value of whole numbers as a fraction. C, the student does not understand conceptually how to multiply fractions. Or D, there is not an error. The student is correct. So when we read this problem and whenever I do error analysis, I always will read the problem, solve it myself, compare my answer with the student's answer or compare my work with the student's work. Because by doing that, I can quickly see the student's error because sometimes when we're under the stress of the test and we look at the student's work at a glance, it's often going to quickly look correct because, again, we're looking at it under a stressful situation, which we are taking this test. And so I will usually, almost always, solve the problem and then compare my work to the student's work. So Jamie is having this cookie party, right? And her cookie recipe calls for 2/3 cup of sugar. And she wants to bake 4 batches of cookies. So I'm going to multiply 2/3 times 4 because I need to do 2/3 4 times. To multiply a fraction by a whole number, I need to convert the whole number into a fraction. And so I can say that 4 is the same thing as 4 divided by 1, right? And then I can just multiply straight across. So 4 times 2 is 8. 3 times 1 is 3. So she's going to need 8/3 cups of sugar. And it looks like this student got 8/12. So what did this student do incorrectly? Well, when we take a look at this problem, I see that the student started with the 2/3, which was absolutely correct, and then multiplied times 4/4 instead of 4/1. And that is where the student made their error. Now, let's see if they understand multiplication just as a concept. 2 times 4 is 8. That is correct. 2 times 4 is 8. And 3 times 4 is 12. That is correct. So the error was in the multiplication of the whole number. So now let's look at our answer choices and decide which one is correct. A, the student does not understand how to multiply. Well, that's not accurate because the student does understand how to multiply. They can multiply 2 times 4. They can multiply 3 times 4. They may not understand how to multiply fractions, but they understand how to multiply. Is there an error? There's absolutely an error. So we are between B and C. B, the student does not understand the value of whole numbers as a fraction. Or C, the student does not understand conceptually how to multiply fractions. The student conceptually understands how to multiply fractions because the student knew that they needed a numerator and a denominator. So they had to take this 4 and somehow convert it into a fraction. And the student also knew that you just multiply straight across. So the problem is not in the conceptuality of multiplying fractions. The error is in understanding the value of whole numbers as a fraction. The student did not understand that the value of 4 is not the same as 4/4. The student did not understand how to convert that whole number into or as a fraction. That was where the error was. And this can be really, really mind-boggling and cumbersome to work through because tiny little tweaks in each answer choice could make it be correct. So that's why when we're looking at these problems that are so lengthy, it can be difficult to interpret them. I don't disagree. Hey, Claudia, it's good to see you. Happy birthday. Thank you. And tiramisu is your favorite. When I was a kid, I was obsessed with tiramisu. Now I have yet to find a tiramisu that is gluten-free, and that's very sad. But I love tiramisu. A vanilla birthday cake gal. I love that. You're new to Texas. My husband grew up in Texas, and I would love to go back. And you're teaching pre-K this fall. Congratulations. Hey, Hope, it is good to see you, my friend. I haven't seen you here in a while, and your favorite cake is chocolate and amaretto. I love that. But I'm just happy to see you here. I haven't seen you in a while. All right. I could sit here and chat with you guys all day. We'll really chat with myself and look at your comments, but we got to do the next math problem. So let's go on to problem 2. The sum of the digits of a certain 2-digit number is 15. Reversing the digits gives a number which is 9 less than the original number. What is the original number? So the sum of the digits of a certain 2-digit number is 15. Sum, answer to an addition problem. Digits, like each individual number in a multi-digit number. We're looking at a 2-digit number, and when I add those digits up, it's going to equal 15. So I am going to go ahead and look at my answer choices. Because in this kind of situation, using my answer choices is going to help me the most. So yes, I could come up with like some sort of equation or process to solve this, but when I have answer choices there to help me, why would I do that? Let's go ahead and look at that. So 6 plus 9. 6 and 9 are the digits of 69. 6 plus 9 is 15. 7 plus 8 is 15. 8 plus 7 is 15. And 9 plus 6 is 15. Okay, so that did not help me at all. But I promise you sometimes it does. So now I have to look at the second condition for this problem. Reversing the digits gives a number which is 9 less than the original number. So if I reverse the digits of 69, I get 96. If I reverse the digits of 96, I get 69. Do either of those give me a number that is 9 less? No. 96 and 69 are not 9 away from each other. So I already know that A and D are out. B and C. Reversing the digits of 78 gives me 87, and reversing the digits of 87 gives me 78. Are 87 and 78 9 digits away from each other? They most certainly are. They are 9 away from each other. But now I have to figure out what exactly did it ask for? What is the original number? If I reverse the digits of the original number, it gives me a number that is less than the original number. If I reverse the digits of the original number, reversing the digits of the original number gives a number that is less than the original number. Interpreting the words is the hardest part of this test. Reversing the digits gives a number that is less than the original number. So if I reverse these digits, does that give me a number that is less than the original number? It does not. If I reverse these digits, does it give me a number that is less than the original number? Yes, it does. So C is the correct answer. All right, let's go ahead and move on to problem 3. Find the center and radius of the circle. Find the center and radius of the circle. All right, so we have x squared plus y squared minus 6x plus 4y equals negative 4. And they want us to find the center and the radius of this circle. The best way to do this, unfortunately, is to complete the square for each of the x and the y to figure out what the equation of this circle is in standard form. Because it is going to be really difficult for us to find the center and the radius when it's all broken apart like this. So this is definitely for my 6 through 12 test takers. If you're taking an EC6 or a Praxis elementary, you are not going to need to know this. But if you're taking a high school or a middle school test, I would absolutely suggest that you pay attention. Otherwise, you can take a break until the next question. Don't leave me. You can still hang out. But this is definitely for my upper level friends. So, completing the square, not my favorite process, but becomes super helpful when you have to do something like this. So I'm going to put my x terms together and my y terms together, and I'm going to leave the negative 4 as it is. So x squared minus 6x plus y squared plus 4y equals negative 4. Now, the process of completing the square puts this in standard form. It can also put a quadratic in vertex form. And what I'm trying to do is get my trinomial, my x squared minus 6x plus something, to be a perfect square, okay? So follow me through this process. I'm going to do x squared minus 6x plus blank plus y squared plus 4y plus blank equals, this is where it gets tricky, and this is where people usually make a mistake. -4 plus blank plus blank. Why did I just do plus blank on the right? Now, elementary people, if you go through 6th grade, you should at least know the answer to that question. Whatever I do to one side of my equation, I have to do to the other side of my equation. Whatever I do to one side of my equation, I have to do to the other side of my equation. So if I'm adding a plus blank here, I need to add a plus blank here. And if I'm adding a plus blank here, I have to add not erase, I have to add a plus blank here. Now, what goes in that blank? B divided by 2 squared. So I'm going to do -6 divided by 2 squared, 4 divided by 2 squared, and then whatever those are, go in those blanks. So -6 divided by 2 is -3 squared is 9. So x squared minus 6x plus 9 plus y squared plus 4y. 4 divided by 2 is 2 squared is 4 equals -4 plus 9 plus 4. You following? Now, technically, I could stop right here. Technically, I could stop right here. Why? Because I know that the equation of a circle is this: x minus h squared plus y minus k squared equals r squared, where hk is my center and r is my radius. So if this is going to create this part of my equation, and this is going to create this part of my equation, and this are going to create, and I don't have any of the same radius in my answer choices, can't I just solve this part right here, find my radius, and be done? -4 plus 9 plus 4 is just 9. My radius is not 9, though. Remember, in the equation is formatted such that the r is squared. So 9 equals r squared, not r. So I need to square root the 9, which is 3, which automatically tells me that my answer is A. Now, how do we finish this completing the square process? What if all of my answer choices said the radius was 3? Good question. Let's go ahead and finish this problem. Now, by doing this whole process, what I was doing was creating perfect square trinomials, which means when I factor these, I'm going to get 2 binomials that are the exact same thing, 2x minus x plus that are the exact same thing. So I could sit here and try to factor it, but the beauty of completing the square is that I know it's going to be x plus whatever the b divided by 2 part is without squaring it. So b divided by 2 was negative 6 divided by 2, which was negative 3. So it's actually going to be x minus 3 squared plus, see if you can do the y part. Y, b divided by 2. B divided by 2 was 4 divided by 2, which equals 2. Y plus 2. So my center is 3, negative 2. Why is it opposite? Why isn't it negative 3, positive 2? Because the original formula for the equation of a circle has a negative h and a negative k. But the center is hk. So because of that, we have to do the h and the k opposite what's inside. Does that make sense? All right, let's go ahead and move on to problem number 4. What is the vertex form of the equation shown below? Now, I had just finished saying you could do completing the square to solve this problem. You could. But I also just got finished saying I don't love completing the square. Completing the square is a cumbersome process. And so when I look at my answer choices, I am going to look at them and say, none of these are the same. They all have a 3 in the front. So, okay, fine. But none of this is the same. It's all different. So couldn't I theoretically just find my vertex and then that would be the vertex form of the equation? Yeah. How do I find my vertex without putting it into vertex form? And this is vertex of a quadratic only, which is vertex of an x squared problem. How do I find my vertex? Well, I can find the x value of my vertex by doing negative b divided by 2a, where a is in front of the x squared, b is in front of the x, and c is by itself. It's the constant, equals f of x. So in this case, what is a, what is b, and what is c? What is a, what is b, and what is c? A is going to be 3. B is going to, whoops. iPad likes to do that sometimes. Welcome to Wednesday Night Math Night with Amy Sink. You know, I was actually just thinking, my iPad hasn't disconnected for a little bit. And then here we go, disconnecting on me. So let's go ahead and see. There we go. Okay. So my A is 3. My B is 6. And my C is 27. So I can do X equals negative B divided by 2 times A, which is 3. Negative 6 divided by 6 equals negative 1. Again, theoretically, I could stop there because vertex form of a parabola is f of x equals a x minus h squared plus k, where your vertex is h comma k. So my h value is going to be the opposite sign of what it actually is, but my k value is going to be consistent. So if the h value or the x value is negative 1, then what is my vertex form going to look like? X plus 1, because it's going to be opposite. The only x plus 1 we have is letter B. Y'all, this week, I'm really just trying to show you how to not waste time, which is super valuable when you're doing this test, when you're taking this test. I don't want you to spin your wheels on stuff that don't need to be spun. Now, what if, I know what you're asking, well, what if it was 3 parentheses x plus 1 and there was 2 answers like that? Well, now, what do I do when I have an x value for anything and I need to find the y? Elementary people, what do I do when I have an input and I need the output? What do I do when I have that x value and I need my y value? Plug it in. So I'm going to take that -1 and I'm going to plug it in. So 3 times -1 squared plus 6 times -1 minus 27. -1 times -1 is +1, so 3 times 1 is 3. 6 times -1 is -6 minus 27. Handy dandy calculator. 3 minus 6 minus 27, -30. Bada bing, bada boom. It matches. Questions? Thoughts? Concerns? Thinking about what you want to go over next week? Let me know. As we're working through these problems, let me know what you want to see next week or in the upcoming weeks. Concept, or maybe there's a problem you've been struggling with, or maybe there's a section that you're struggling with. Why H and K? Lydia, that's a great question. I don't have an answer for that because whoever created the formula decided that HK was going to be the vertex of a parabola. I always remember the H is the X and the K is the Y, though, because the X is attached to the H. And H comes before K in the alphabet, so X comes before Y in the alphabet. So that's why it's H comma K, X comma Y. But you'll notice a lot of times when we're looking at like pre-calc algebra 2 stuff, the equation for anything with a vertex is HK. The equation of the center of a circle is HK. So they just really liked HK, I guess. I don't know why not ST. I don't know why not BC. I don't know. I don't know if there's a reason. It's just HK. That was a great question, though. That was a really good question. All right, let's go ahead and move on to the next problem. Ooh, this is small. A 7th grade math class is working with similar figures. The 2 cylinders shown below are similar. Mrs. Melendez told the class that surface area of the cylinders are 251 2/10 and 1004 8/10 square units, respectively, and that the volume of the smaller cylinder is 301 4400 cubic units. He challenged his class to find the volume of the bigger cylinder. What is the volume of the bigger cylinder? Lydia, you are so welcome. Listen, I can understand why someone would be lost on that. I mean, that could be confusing. All right, looking at similar figures. Now, we have talked about this before. When we are comparing similar figures, we know that we have a common ratio. So we know that like everything from here to here is going to be multiplied by 2 or by 3 or by 3/2 or whatever the common ratio is. However, that common ratio applies to linear measurements only. It does not apply to area and volume exactly. Now, yes, there is a way to figure it out, but you can't just multiply it. So I cannot set up a proportion. I cannot do this. 1004.8 over question mark. Why? Because the scale ratio between these is not the same. The scale ratio between those is not the same. So then what in the world am I going to do? Well, I have to figure out what the linear ratio is, and then use that to figure out what I need to multiply this by to get to this. So I have 104.8 and I have 251.2. I'm going to divide those. 104. 1004.8 divided by 251.2. Let's see what that is. That equals 4. What does that mean? That does not mean I take 301.44 and multiply it times 4. It does not mean that, because 4 is the square volume, 4 is the square of the ratio, because we're dealing with square units. So I need to square root 4 to figure out what the linear ratio or the linear scale factor is really what I should write. The linear scale factor is, which means the linear scale factor is 2. Now, how do I figure out the cubic scale factor? It's not rocket science. The cubic scale factor is going to be 2 cubed. 2 cubed is 8. So I'm going to multiply 301.44 times 8. I'm going to multiply 301.44 times 8. And that's going to give me 2,411. Now, some of you were really trying to figure out how you were going to solve this because you didn't have the radius or the height. And then it becomes a little difficult because you're like me. You wanted to solve the surface area and then solve the volume. But it becomes very difficult to do that when you're not given the measurements. So that's why understanding scale factor relationships is critical. Questions about that? All right, let's go ahead and move on to the next problem. I'm actually going to skip the next problem or two because I want to get to this next, this problem that's really problem number 8. And then we'll circle back to whatever we have time for. But I feel like we've done a lot of upper level, and I want to hit my EC6 and pre-K people. So let's go ahead and read this problem together. A kindergarten teacher is trying to assess her students' abilities and identify and describe shapes. Which would be the best example of a formative assessment method designed to provide the most accurate reflection of student progress? Okay. Before we read these answer choices, I'm going to think about what is it asking me again, because sometimes I really, really struggle with comprehension when it's this kind of problem. So we read this problem and we go, what did it just ask me? Right? So what is the kindergarten teacher trying to do? She's trying to assess her student ability to do what? To identify and describe shapes. That's what she's trying to do. She's trying to assess the student's ability to identify and describe shapes. Those are the critical words. And now we're looking for a formative assessment to provide the most accurate reflection of student progress. Now that we know what we're kind of looking for, now let's read A, B, C, and D. Once a week, the teacher asks, who knows which shape is a triangle? The teacher then records the names of students who raise their hands, selecting a different shape each week and monitoring the responses. So next week, she might say, hey, who knows what a square is? Hey, who knows which one the circle is? And that's what's happening. B, at the end of the school year, the children take an online quiz with auditory directions such as, can you find the triangle? Click on the triangle now. The teacher then reviews the resulting data. C, on a daily basis, the teacher asks, can you draw a triangle and turn it into an animal? The teacher then retains student drawings for a portfolio, offering different prompts for creativity each time, such as fruits or toys. So can you draw a triangle and turn it into a fruit? Can you draw a triangle and turn it into a toy? Or D, periodically, the teacher directs students to draw a triangle on your paper. Then the teacher asks each child to explain what makes the shape a triangle, noting the responses and the alternating shapes. So the first thing that sticks out to me is this. At the end of the school year, what does that tell me? That tells me that this is a summative assessment rather than a formative assessment. Remember, formative is going to form our instruction. So it's going to happen more often than a unit quiz or a unit test or at the end of a quarter or at the end of a semester or at the end of a school year. That is not formative assessment. Formative assessment is like a midweek quiz or an anecdotal observation or an exit ticket. Those are all examples of formative assessment. And they happen more often because then we can actually form our instruction, right? So A, once a week, on a daily basis, periodically, all of those would be considered formative. Now, I don't want you to get stuck on periodically because periodically could mean every other month, but periodically could also mean every other day, really. So we don't want to get hung up on that because on a daily basis sounds better for formative than periodically, right? So now that we've gotten rid of the summative assessment, now we need to figure out which of these is the most accurate reflection of student progress to identify and describe. Are students identifying and describing in A? Are students identifying shapes and describing shapes in letter A? No, they're not. In fact, they're not really even identifying. If the teacher says, who knows which shape on my board is a triangle? And 5 kids raise their hand in a kindergarten class, how does she know those kids actually know what the triangle is? Let's think about what a kindergarten class really looks like. When one kid does something, what happens? They all do it. So I'm sitting next to my friend and I have no idea what a triangle is. In fact, half the time I'm spaced out and I don't know what's going on in class ever. But my friend raises her hand. So what am I going to do? Because I want to follow the rules and I want to be compliant, but I have a hard time focusing. I see her raise her hand and I'm going to raise my hand because that's what everybody else is doing. I don't know what a triangle is, but the teacher doesn't know that. The teacher doesn't know that I don't know what a triangle is because all she said was raise your hand if you know what a triangle is. She didn't say, hey, tell me what that triangle is. Point or even point to the triangle. She didn't do any of that. So that, while it sounds like a great idea, the teacher has no clue who can identify or describe a shape. So now we're down to C and D. Which of those activities allows students to both identify and describe? Which of those activities allows students to both identify and describe? D. We're not looking for what activity would you choose to do in your classroom. We're not looking for what activity is the most fun. We're not looking for which activity seems like it would engage kids the most. We're looking for which activity is the most accurate reflection to identify and describe shapes. And that all day is D. Because this, again, can you draw a triangle and turn it into an animal? And then she shoves them away in a portfolio. Well, it shows that I could draw a triangle, but it doesn't show that I can describe the attributes either. But if the teacher is asking each child to explain, noting their responses, and then alternating shapes, that teacher is really trying to figure out what those kids know, what they don't know, so that she can form her instruction. All right, that was a lengthy explanation, but I really wanted to showcase how to work through these kinds of problems, what you're looking for when you're solving these lengthy, thick problems that are often on MTTC, EC6, FTCE. Like, those problems are going to be thick and heavy, and they're not scary. We just have to know what we're looking for, right? All right, let's circle back to problem number 6. The table below shows Sarah's class schedule for a week. On Wednesday, what fraction of the day from 8 o'clock to 2:40 is she scheduled to be in class? On Wednesday, what fraction of the day from 8 to 2:40 is she scheduled to be in class? So we're looking at Wednesday, which is this section right here. And we're only looking for what fraction of the day between 8 and 2:40. We're not looking for fraction of like her whole 24-hour day. We're only looking from that 8 to 2:40 section. So what fraction of her 8 to 2:40 day is she scheduled to be in class? Let's remember that a fraction is just a part over a whole. That's it. Now, the whole could be a candy bar. The whole could be a day. But the whole in this case is this part of the day. That is the whole, because they're asking what fraction of that part. So that is the whole. The whole is 8 to 2:40. So the best way to do this is going to be to figure out how many minutes I have from 8 to 2:40, and then figure out how many of those minutes she's in class. The tempting thing to do is to count up blocks and figure out how many of those blocks she's in class. So she has 1, 2, 3, 4, 5, 6 blocks. And out of 6 blocks of her day, she's in class 2 out of 6. But I caution you on that, because when we look at this, there's a gap in her day right here. There's a 5-minute gap. Here's another 5-minute gap. Here's another 5-minute gap. Here's another 5-minute gap. Here's a 15-minute gap. And these sections are all the same. This is an extra long section. So it's not even an equivalent block to the rest of the blocks. And that's what they were trying to trick you on. So I need to figure out how many minutes are in my chunk of day, and then how many of those minutes is she sitting in class? Let's get our calculator. Let's start with how many minutes is she in class? She's in class 55 minutes here for math and 55 minutes here for history. So she's in class 55 plus 55. 55 plus 55 is 110. And how many minutes are in her day? Well, we know that there are 60 minutes in 1 hour. We were so close to finishing the lesson without disconnecting again. So we know there's 60 minutes in an hour, and I'm going from 8 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 1, 1 to 2, and that's 6 whole hours. So I'm going to do 60 times 6. 60 times 6 is 360. Plus the extra 40 minutes to get from 2 to 240. So my fraction is 110 out of 400. But I don't see that over here. It doesn't mean that I did something wrong. All it means is I need to simplify my fraction. So I'm going to do 110 divided by 10 is 11. 400 divided by 10 is 40. And my answer is C. All right, let's take a look at it didn't even connect. Here I am like finishing this problem, writing all over the screen, and y'all are like, we can't see it. Here you go. Now you can see it. All right, let's do one more problem, which is the same. It's the same chart, but I wanted to ask a different problem about the same chart, and then we'll close it out. So here's a picture of Sarah's class schedule. What fraction of the scheduled week is Sarah in history class? So now we're looking not at a day, but we're looking at how much is she in history class. Now, the tempting thing would be to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. There's 4 history blocks, 4 out of 30. But you and I both know why that's not going to work. If you don't know, go back and listen to the problem I just did, because I explain why that's not going to work. That's not going to work because the blocks are not the same size. There's a chunk that's missing in the middle of each section. There's a break. So we don't want to do that. So we want to figure out how many minutes in our scheduled week that we have. Well, we already know that we have 400 from the previous problem in one day. How many days do we have? 5. 400 times 5 is 2,000. That's my whole. What is my part? The most common error is people are going to see that this is a 55-minute block, and they're going to do 55 times 4. However, history is 55 minutes here, but it is not 55 minutes here. So we can do 55 times 3, but then we have to add whatever this chunk is, which is a whole hour from 1 to 2. So that's 60 minutes plus an additional 40 minutes to get from 2 to 240. Then we have our fraction. So I have 55 times 3 is 165 plus 60 plus 40 is 265 out of 2,000. Do we see that answer here? No, but we just have to simplify. 265 divided by 5 is 53. 2,000 divided by 5 is 400. 53 out of 400 is our answer. Questions? All right. I'm going to turn it back over to Dr. A. But I want you to think about, what do you want to see in the upcoming week or weeks? Let me know in the comment box. And I hope that you guys have an amazing week. I will have an amazing birthday. And I hope that you guys have an amazing week. I will see you next week. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.